All right. Hello, everyone. I am John Ricco, Executive Director here at the Architectural Precast Association. Welcome to our webinar today on 3D modeling, how to make your software work for you. We thank you guys for being here today and for taking the time to participate. We are going to few announcements here before we get things kicked off. Just wanted to make you aware of some upcoming events and some information here at the APA. We've got our upcoming annual convention on October 25th through 28th in Utah. We're looking forward to being out in Park City again. We've got a great opening keynote session on leadership that Stephanie Giesler with Vistage is going to talk with us about. In addition to that, the remainder of the educational sessions at the convention will be focused primarily on making the complex look easy is what we're calling it. It's about molds and mold making and forms. And so we'll have Eric Sutliff with DaVinci Precast talking about their Greenwood Rising Museum in Tulsa. Rosario Gallo with Scott System will be there to talk about Pier 55 in New York, that project that they worked on. In addition to that, Matt Gehring and Dustin Williams with Unlimited Design will be talking about the Populous Hotel project. And we've got one more that we're finalizing that we're looking forward to announcing very shortly here. But things are rocking and rolling and underway for the annual convention. So we're looking forward to seeing all of you out in Utah. We always like to remind everyone, especially those of you who are APA certified in terms of your personnel, you have continuing education requirements that you have to meet every 3 years as part of your cycle. It's a lot easier than it might seem to earn those continuing education credits. But if you have any questions, I mean, this webinar here is a great way to do that. And so if you have any questions on earning credits or what counts or what doesn't count, please feel free to reach out to us here at the APA offices, and we'll be glad to answer any questions that y'all might have. There's a ton of stuff on our YouTube channel. That's probably one of the best and easiest ways to earn CE credits. You can see there's a variety of topics. We've got it segmented by mixed design and reinforcing and compressive strength. There's a variety of playlists there that you can view and earn CE that way. So we like to make sure everyone's aware of that. In addition, we've got some cost-saving programs for our members, shipping through UPS, as well as some Office Depot office supplies as well. So check those out when you can. And then we have a free member HR hotline. You've got a quick question as to, dotting I's and crossing T's in terms of what's going on with your personnel and actions you may or may not need to take. Quick phone call, and they'll provide you a free consultation over the phone. So look on the APA website for information on that as well. So with that, let's go ahead and kick things off.
Hey, John, and hello, everybody else.
Welcome, Rod. Thanks for being here today. I'm going to give a little bit of a bio. But before I do that, I just want to let people know that if you're logged into a YouTube channel, you can submit questions through the chat feature, which you'll see, I think, on the bottom right-hand side of your screen. If you are not logged into a YouTube channel, you can still submit questions. And as we go through the webinar, what will happen is there'll be a scrolling banner across the bottom that'll give you the email address where you can shoot a question via email. So with that, let me welcome Rod. Rod Johnson. He's the president of Lucas Concrete Products. Since its founding in 1971, Lucas Concrete Products has grown to serve a wide spectrum of the precast market, from hand-set fireplace surrounds to boutique work, all the way to spandrels, columns, and brick inlays. They've done just about all of it. It was established by cousins John Johnson and David Lucas, and the company initially set out to be part of the utility market, but by 1973, David Lucas left the company to pursue other interests, and Lynn Johnson joined the company as a partner. In 2000, Rod left his career as a technical sales rep to join the family-owned business, and he became majority shareholder in 2005. Prior to joining Lucas, Rod worked in Basic Industries Group as a sales consultant with a focus on power, steam, and water treatment in the nuclear, power, pulp, paper, and steel industries. He holds a bachelor's degree in science and engineering from North Carolina State University. He married his wife Donna in 1995, and they have 3 adult children, Luke, Reagan, and Gavin. So welcome, Rod. Glad you can be here, and I'm going to go ahead and turn it over to you.
Fantastic. Thanks. I appreciate it, John. And hello to everybody that's out there watching. I'm not going to pretend like I'm a professional presentator of any sort. but everybody does know I like to bloviate and talk. So I'm going to do my best to kind of walk us through a little bit about our experience from the 3D modeling world and how that's kind of uh, affected our company, who has always been really primarily almost always a hand built of everything from the mold work all the way through the finishing process. And so um, our evolution as we kind of came through this is I always kind of try to do some 3D modeling, even when I started out using third-party softwares and that kind of stuff. But we never could figure out how to ultimately integrate it into our production. I used a product called DesignCAD, which is basically a very cheap version of AutoCAD, which most of our employees have used AutoCAD. Then we started to integrate Inventor for 3D modeling because it was much more robust. And then eventually we ended up finishing off with Fusion 360, which we found when we were ready to make that step from using a 2D model to a 3D model and then try to use that integrating into actual production. So what we would typically use in your 3D modeling is for sales. That's what I would use it for. And I get told by the guys in the office, anytime I don't put heavy detail into the model, but turn it over to them to use it, they're like, well, it's for sales purposes. Well, the reality is it is effective. It does allow the client to see things, whether it's blends it into reality to kind of help them visually understand what you're trying to present, how you're going to solve those problems. You can show them from an element of scale. And what I'm also going to do is on here, I'm going to bounce from the presentation, by the way, to a couple of different pictures and folders and stuff like that, just so you can understand what we're talking about that's on here, for example. So the 2D world, for example, I'm going to bring this into here, give you an example where clients often see those hard lines that we do in a 2D model, especially when it's on lines and stuff like that, hard line, black line against white paper, but they need to see how it's going to really work in the real world. This helps them in the decision-making process a lot of times is what we feel, because he can then go back and again show them where that might need to happen. And again, this particular product that I'm doing and all this in is in Fusion 360. This is just a good tool to kind of walk through those kinds of things with the client. Another example was where you might bring something like this into a 3D world so they can understand how you're going to part out part of their project. Panelization, for example. Hey, in this particular case, the client really just wanted us to do wall cap that was on here. When we looked at it, we're like, well, why wouldn't you just make this all out of precast? This is what we would do. And in a matter of a couple of days, you could set it all as opposed to trying to pour it in place. That all comes from a sales presentation of using a 3D model. Okay. So another way for me to show you that is, for example, we had a client, this just kind of blew them away, being able to pull in parts and pieces and letting them know, hey, this is how we would set up your panels to help them understand where we're going to put the joints, how we would locate the brick, how do we blend that in so that it goes from concept to reality. Those are the kinds of things that we're trying to show that's on there. And I think here we go. Apparently, I thought I was showing you this and I wasn't. But this is a concept to reality type application where we're showing the client, hey, this is what we're thinking. Here's what it would look like, for example, in your environment. You know, you could take a background photo, drop it in there for them. These are good ways to take 3D modeling from a sales perspective. But the real question is how do we pick up the next element that's out of here? Okay. And that's really kind of where what we do from a best practices and what we feel like is 2D still has a place. You really want to have 2D. You really want to cut your tooth on this first is what we believe. And again, your shop drawings that go out to the client, it's fine to integrate some of the 3D modeling to help them see those things, but we really like to slice and dice things on 2D, mainly because you can tie back to things like column lines. You can tie back to sections that go back to the contract drawings. But the main thing is you could still integrate those two things together, but we find that there's a limitation in the 3D modeling drawing profiles, meaning like it doesn't do as good a job picking out nodes and sections and details that you need to try to integrate. So what we're going to do is I'm going to bounce back into this, for example, and we'll bring up this project as we're kind of looking at both of these things here. Let's see here. So we're going to go back through and kind of bring this project. I'll walk through this particular job as well as we kind of go through this, because again, the Fusion 360, which is what we're using, is part of the Autodesk family. Okay, there are other products like SolidWorks you can use. There's a few other things that are out there you can use, but in general, in the industry, if you're going to have a singular software that's going to talk directly to your CNC equipment, you may as well learn one of those two as an integrated into it. And we found that you go with Autodesk, you can incorporate Revit, which a lot of people are using in 3D modeling for on the architectural side, with AutoCAD and Fusion 360. Okay, so let's just kind of go through some of that. So the family, it's very similar in terms of the tools. The second thing is how this works is you're using bodies, okay, in addition to components. I'm going to pull up this fire pit and share that with you as I kind of look through the our notes that are on here. Let's see here. There we go. So you can see this. So this particular case where we're using the 3D model as opposed to the 2D drawing for whether it's presentation to the client or whether it's presentation to what we need internally to the office. This will take it a second just to update. Okie doke. So now you can see the difference between the model and the 2D drawing. The thing that we find on these is you can't quite get the information you want in terms of the connection or snapping, for example, dimension tools and getting it in the way that you want to present it. So you may end up having to take this item, export it out, okay, as a DXF, and then import it back into 2D. But in this particular case, we find that you can get a lot of information out of this singular part that we have that's on here. And as you can kind of see that's on here, this is one single part. You have timeline through the bottom that goes through this that creates anywhere from, you can see here, it's a singular body, and I was talking about bodies and components. That's what we end up using that's on here for how it's eventually going to talk to or deal with a CNC piece of equipment. Okay, so but what's great about the software in general is you can also integrate things like your own texture of your own concrete. So in this particular case, we actually took a photo of our concrete and mapped it onto this product. So that actually shows every tiny little nook and cranny. You can increase and decrease the scale, but it adds a certain amount of reality, particularly if you're going to go to a presentation mode where it goes to a higher level of rendering and those kinds of things. But going back in the design element, and let me go back over here. You can generate realistic images. You can import and export just about anything you want into these 3D models. Okay, and then from there, you can then break it apart to get the formwork, which is really the primary element of this, is to get the formwork. And so as we kind of go through this a little bit, before I get into where we get into that part of it, the question becomes, hey, how do I manage this data? How do I manage these files? And so what we do best practice wise is we make sure we kind of go through how do we manage our data on our like PC local information, and then how does it look onto the cloud? Because this particular product is done on the cloud. And then why is that important? And it's important for us is because I could be working on a particular part at the same time that somebody else is working on a part. If there was an issue where we had two different versions, it'll save both versions, and then it will warn us and let us know, hey, there's a newer version of this, or hey, there's an updated version of this, and then it lets you know who the user is that's on that. So understanding that file management and then the collaboration within your office is important. So we try to make sure that those things mimic each other. Okay, so now what about the 3D modeling and how does it work for you? Our first exposure was to do 3D printing. And we ended up doing this primarily for the client's purpose. We were dealing on a particular project where what we would call competing geometries, where the client had a 2D image that they were showing, and they were like, hey, this is what we want it to look like. And every time we would go back and try to show them in the model, we're like, hey, this will not work in the section view and the plan view and the elevation. It's not reality. And so we had to kind of work back and forth with the client to make sure that we were getting, for example, this type of cusp that was a radius as opposed to a sharp edge. I can't remember which one we ended up going with. So our first set was to just go straight to 3D printing. We eventually ended up, and kind of going through this whole aspect of it too, we eventually ended up going to where we had 3D CNC. So we kind of skipped from 2D printing to 3D CNC, but we exported it out, had another company actually perform this work for us. So in terms of how that worked for us as a company, go back to this right over here. That was part of this whole 3D printing aspect. We were able to take inventor models, push them to a 3D printer, and then print them out. Ultimately, what ended up happening is that kind of made us think, hey, if we're going to go ahead and do that large scale column, which is what we would typically do, is take this, still print it all out in 2D, and we ultimately still cut all these individual pieces out on this particular project. Okay, where we had staged elements, and we were doing a lot of marking of product, printing it out. I think we had somebody print this out to us, or actually they CNC a small section. We took a plaster mold of it, made a bunch of pieces off of it. This ultimately, this volute that was on this column, all same part of the column, was all made by hand. It was a laborious process. It takes your most skilled labor, it shuts them completely out. But as you can see, we basically still were printing out 2D images to create the 3D form. And then eventually kind of combine some parts and pieces of 3D into creating the formwork. Again, we made rubber molds off of this. That was all done by hand. But by the end of this particular project, okay, we ended up saying, hey, how do we expedite this? And working within the APA, we found some guys that actually took one of our molds and cut it out into a 3D section for us, which we'd never really thought we could do. Ultimately, we ended up having this entire back half of this project was cut with the CNC, and then we made either a rubber mold off of it, or this was an MDF material that was kind of put together as we saw here, poured it vertically, and that was it on the down the road. So in one project, we went from hand built on the front end of the project to machine built material that was done on it. And it came out fantastic, and it cut a lot of labor out for us because we were able to kind of focus on other things with the mold shop. So that was kind of the big steps for us in terms of when we decided to go ahead and integrate and go from 3D modeling to 3D printing to 3D parts being cut out on a CNC. But over the last year or so, or really last 2 years, we ended up losing a worker that was one of our highest skilled set guys, which is what made us decide, hey, it is now time for us to bring in the 3D modeling, okay, into our plant. So with that, I'm just going to kind of walk. I don't know if anybody has any other questions, if I'm getting ready to kind of step right into this next phase, because we're really going to kind of go into a couple of projects where I'm gonna go from smaller projects to larger projects, and where we kind of cut our teeth on it. I got like 3 small projects. Anybody have any major questions on the front end at this point?
Not at this point, Ron.
Okay.
We're monitoring it.
All right. Sounds good. So this particular project right here, this is when we got our very first CNC. Okay. And so within the first week, we decided to try out individual parts and pieces to cut out ribs for a column. It worked out great, with the exception of this drawing file took way too much time, way too much effort, because I thought I was going to slip in these small pieces in between each, and I thought I was going to save a lot of time. Well, I didn't. I spent an enormous amount of time, but the reality is the product and how it cut it all out. You can see the little shop ticket that we have that's right here. That was kind of laid out all onto this particular project that was on here. Let's see here. Give me a second. This is how we kind of cut our teeth on our first project, where we decided, okay, we're going to cut a series of ribs out. And then these were rather large columns because the diameter of the column was over 4 feet in diameter. And so it required us to basically create a dovetail slot between the pieces and the parts. So that was one of those things where we're like, okay, well, we can go ahead and put this on here. And then I read somewhere that the software allowed it to basically be arranged automatically onto a flattened sheet of plywood. That did not work nearly as well as we thought it would. So that's kind of one of the limitations that you run into, is you can't get away without 2D. This took a lot of time for us to do. It was kind of like a first one to kind of learn on. And let's get back to the image of the picture. So what we ended up doing is learning from our mistakes that was on this. This particular project had 2 different diameter sizes. I forgot. This is the shorter of the 2. I showed you the larger of the 2 columns that was on this particular project. That's the larger of the 2 columns. This formwork, which was one that has a mold on an entasis that was on here, and then this was just a straight shaft that was a little over 4 feet in diameter, which is what you see here. Going back into that was our first kind of stab at this, is we realized, okay, what do we need to fix from that? So as going back down, we decided, okay, like on the next project, which was what we ended up having here on this, which is the fire pit. Okay, this is the example I was showing here. This is relatively straightforward to show in terms of a drawing file. And in terms of how do you go through and draw it, what I like about Fusion 360 is it has a timeline at the bottom. And it's a really straightforward step-by-step process that goes on to here that I can show you. We can record something like this, for example, and show you each and every step that goes through here in terms of the extrusion, in terms of how you would create new planes, et cetera, that walk you all the way through it. And then the back half part of that is, how do you then turn around and integrate this into the formwork, which is what this part of it here is. So going back through this, the first part of it is how do you integrate this into formwork? It gets back to the 2D drawings. In this particular case, we did all the 2D drawing in the Fusion 360 and basically laid out each component of how we wanted to see it, extruded it up, and basically from there, we built out every individual component in the 3D model, if that makes sense. And then once you create your models, okay, where you have your bodies that are laid out in here individually, okay, and ideally you would go through it and label each one of these bodies. Hey, this is unit A, this is unit B, this is unit C, and then you would create components. And in this particular case, this is where we named them, was that we named the components into before we went through and built things like an array or a pattern. And again, all these patterns, this is all straightforward stuff that you get that's in here. And basically, if I look at this, we determined, hey, we want this unit from the shop drawings. We knew how thick this needed to be. You end up integrating into here the elements of what it's going to look like that's on here. Hey, I want them every so often. And this is what we kind of learned was from our ribs, for example, that on that column section, we realized, hey, we need to do a better job of building how those ribs are going to interface together. And then,
Hey, Ron,
go ahead.
I'm sorry. We've got a question. Just let me know when
Yeah.
you want to jump.
So go ahead.
The question's from Stuart. Why not develop 2D drawings from Fusion's drawing space?
Yeah, well, getting to that, we're going to go back to the Fusion 360 on there for the 2D drawings. You can do the 2D drawings, like for example, back to here. But what we find is, and when you're saying you got to understand is when you go from a model like this, you create a 2D drawing from this, but it's limited in terms of what it allows you to snap and grab onto. For example, I'm trying to give you a good example of what I'm talking about that's on here. For example, this is only going to allow me to give you that tangent of that 5 7/16, when the reality I would have to come in here and slice through here to find out that that thing is not really 5 7/16. It is 7 7/8. It's only going to show me here the 5 7/16 or 9/16 in that case. We find that if you're going to use 2D element that's on here, you can still do it just in the CAD work in the 2D, but where we find it more important is this right here. Again, this process that we were kind of going through that's on here, I 3D built this whole thing and all that kind of stuff. But then as I go to kind of create and lay it out as a templated space onto a sheet of plywood, it wants to automatically lay this out. It does not do a very good job of laying this out. So what we come to find out is a lot of times you might decide how you want to build something 3D. And then what we would end up doing is going straight back into a 2D file. And that's what we're going to kind of get to this next part. We'll go ahead and do it on the oversized forms. In this particular case, we realize that this is very limiting into how you can go in and build these individual parts. It's really difficult for me to kind of come in here and move these around as 3D individual parts to get it where I want it on a sheet of plywood. So this is not a great place to do that. You're better off doing all of that so for example, in this particular case, as we went through and built these individual parts and cut them all out, we found that you were better off going through, in this particular case, we'll come back to that. In this particular case, we were better off taking these individual parts here I don't know if you can see that screen. Here we go. Again, this is me using DesignCAD. As my employees can't stand the fact that I use this still. They all use AutoCAD, but I cut my teeth on this product. We come to find out that it's easier for me to design, in this particular case, an item all in 2D and then take these individual components. So for example, this right here were the ribs that I decided to do lengthwise and longitudinally wise. This is a 24-foot long mold, or 20-foot, 6-inch long mold, and it was 11 feet wide, 11 foot 8 wide. So it made more sense for us to say, okay, I'm going to take this part, draw these out as individual components, and then lay it out this way on individual sheets of plywood that we would then extrude up and out in our CAD model. I have to go back to, so we would export, import, export out into, so you would push out that DXF, for example, one large DXF, for example, that has all this material on it, was pushed out to the AutoCAD, or sorry, the Fusion 360. And in this particular case, you can import all of those individual sheets as one big sheet, or sorry, one big part, so to speak, that is then extruded up into individual components that I am now going to, as we go through this, find each and every, and then when I go into the machining element of it on manufacture, I now have a setup that as a common setup that we would then go through and define how we're going to cut out each sheet of plywood for this particular formwork that was on here. So you have more control over your spoilage of your material. You have more control over the efficiency of it, and you have more control over understanding and labeling individual parts and pieces, doing it out of 2D when you get larger forms, if that makes sense. Kind of give you an idea in terms of what these forms look like. Let's go through, not this one. In this particular case, on this particular project, we used the CNC to cut out and mill out 3/8 inch false joints by taking 9/16 material, milling it down to 3/8, and then cutting them out individually. We also did the same thing with regards to, this is all on the same project that you're looking at that's on here. These are the parts that were cut out. We, again, had the dovetail element that's on here. In this particular case, we treated these as a series of forms that we basically created a bulkhead in between each radius element. So we did that for one reason, mainly because it allowed your least skilled guy can put these forms together at this point. So we had, so again, these were bulkheads that basically allowed this form to get placed together. Let me show you how that happened. So this is kind of a time lapse of as these parts were being cut out down over here, the individual pieces. It was relatively straightforward. The guy that was basically ripping them out on the CNC were able to kind of do a pre-assembly before the form worker guy was able to kind of take it over and fix the individual parts and pieces. So as we kind of go through this, those individual bulkhead parts and pieces were then able to get moved over to the next part of the shop, where then they were basically brought in, squared up, and then the last of it put together on the formwork or on the table as, and then any parts and pieces could be kind of figured out at that point in terms of the fine detail. That allows your more skilled guy is the one who's going to kind of do the fine detail that's on there. But that's how we end up approaching larger forms with bigger parts and pieces that are on there. It still makes more sense to use your 3D, or sorry, your 2D, that lay out a lot of these issues that's on here. I don't know if that kind of answered that question, but I kind of got ahead a little bit on some of these items that are on here. Let's see here. So the fire pit, this particular one is, again, the same thing, where it allows you to build the individual parts and pieces and to assemble them relatively quickly with the lowest, I don't want to say the lowest skill guy, but you don't need to have your highest skill guy cutting out individual parts and pieces. Basically, that's what it's kind of come down to for us. Is what it's allowed us to do is bring in a different skill element, if that makes sense. So now that makes sense. So that was kind of an example on all 2D. If you looked at those couple of projects, those were all 2D items. Basically, you're cutting out ribs, whether horizontal or lateral ribs, to kind of put together. This is a bollard that has a radius top. Okay. Now, you saw earlier that I showed how when we or had another company make us those forms, all of those draft elements that were in those forms for the columns. In this particular case, the ribs that they are cutting out, that bit could get to all of them. In some cases, that worked out fine, but this was drafting that was on there, and it didn't have an undercut. And then the other question is, well, how do I do that on like a domed element? Now, in that image, you saw they had a really large or long CNC bit that could travel. And the Z-axis that moves up and down was also one of the things. We didn't have anything like that when we first tried this out. So what in this particular element, when we went back through and designed out for the formwork on this, we basically kind of created, in the 2D, you basically create in the design space, like you were asking about the sketch plane. And I will say this, the thing is a little bit different on the Fusion Inventor, and I don't know if Revit's like this or not, but unlike AutoCAD, where you draw a line, or you create a command like a line, and then you go X and Y to create the direction where you go. This is a little bit different in that you kind of draw your sketch and then define it in the plane afterwards. So for example, if I'm going to draw a circle, once I've drawn the circle, I can then come in afterwards and dimension it. You don't have to draw it with it. A little bit different. Same thing with individual shapes. Like you can kind of come in and draw an individual closed shape to create a plane, but you come in and define the parameters afterwards. Okay. So that's a little bit different than what you would typically have in a regular CAD drawing. But in this case, on this bollard, we knew that we were going to have a radius shaped face. And so for us, because we didn't have a large bit, we knew we were limited within 3/4 of an inch. We basically ended up creating a series of bodies that we would then come back in, create the form, basically extrude out all the individual parts and pieces that are on here, and in the end, laid it out flat to cut out this will take it a second, on a sheet of plywood, these individual elements. Now, what's different on here when you go to do your form work is up to this point, everything we did was a 2D contour face in terms of cutting out on the machining on these elements that are on here. This is all cut out with what they call the 2D profile that are on these cuts. Basically, once we go through and define those elements, those are all contours of a 2D element. In this particular case here, we actually want to come in and use a different type of tool to create that scalloped form. Again, that can all be done from your CAD software. You just change from a 2D element to a 3D element, and you go to a contour or a scallop. Okay, so that's what this allows you to define 2D versus 3D in terms of cutting. If you have different size bits, you could do a little bit more work with it. So, but at any rate, this has been our traveling. I mean, this has been our experience up to this point in terms of the 3D world that's on here. In terms of training, all of this that we've learned how to use, it's on here for the most part, has been through YouTube. You're either going to use YouTube, you're going to talk to other people within your industry, or you're going to go and just play around with the software and see what each command does for you. YouTube, though, has been pretty valuable, and Autodesk has its own YouTube channel just for Fusion 360. So if you got a question on how to draw something, it shows you pretty well. But the main thing is understanding terminologies that are in here. And so for us, we've been able to integrate basically the 2D and the 3D together, but through mainly trial and error. For example, making sure that you're mating up a dovetail, you're going to have to create a certain tolerance in here so that the product doesn't split or it's not too difficult to put together. Those are the things that we've kind of gone through that's on here. And again, I'll show you a little bit about that, how we ended up running. These show you, let's see here. Am I showing that to you? I think I am. That is how we ended up basically creating these individual. Those individual pieces got cut out, and then we glued them together afterwards, so that we basically got that radius or scalloped face that was on here. And again, any of these models, if you want them or want to see how they were put together, I'm happy to share with you. So, because that's one of the things that's really interesting about the software is no matter what the model is or what the model type it is, whether it's an STL file or SAT file, it will seamlessly integrate that into the Fusion 360. So all of the product we ever did that was out of Inventor that we did for the years prior, we used Inventor from like 2009 until 2000 and until just recently we had to upgrade because of operating system. Some people that are using Fusion, sorry, not Fusion, but Inventor, the downside for it is it's really expensive per seat. And that's kind of getting into why we ended up going with the Fusion 360. It's only $500 a year per seat, which is relatively inexpensive. And you could pay for upgrades for things like nesting and these kinds of other things that are on there, which I don't quite understand what it does. But the Fusion 360 allows you to pretty much do anything you want with any CNC. So kind of going back through here to this, one of the other parts that's nice about it is it allows you to simulate how the product's actually going to cut. So let's try that again. This is where it allows you to also see whether or not you have any parts or any problems with your product. Like sometimes it might want to cut on the wrong side of the line. By visually looking at the product, you can see where you could fix those issues. Fusion allows you to put in things like tabs, which are really important, so the parts and pieces don't move on you or slide on you. It's a very intuitive part of the software that's on that. So probably the final thing that's really good about this is it's also a parametric software, in that if you want to design something that you use all the time. So for example, if we were to come in here and create like a column cap, okay, and we'll say that's 12 inches by, I don't know, we'll say 3 inches, and then it's got a pitch on it that's another inch. And we'll extrude this out, say 4 feet. What I mean by parametric is you can create parameters to this sketch that allows you to come in here, for example, instead of me calling that, I can say that's my width. That's going to be my pitch. And that's going to be my side. You can come in and the extrusion length is actually my length, okay? Once you decide to create these things as a model, you could save this as, for example, wall cap. And then we can just, if you ever want to come in and modify certain elements to it, all you have to do is come in and say, okay, I want a 18-inch wide wall cap, okay? Well, when this is tied to a drawing file, it basically generates the whole new drawing and shop drawing for you. You could save that as a PDF and then start over again with another part. Those are the things that make a lot of sense in terms of ripping out quick drawings and those kinds of things as well. So, all right. I want to open it up and see if anybody's got any questions. I know that I basically have bloviated a lot, shown a lot that's on here, and this could probably be broken down into smaller segments. But we have come to find that the Fusion in particular, in terms of how we've been able to integrate it into making our form work, has been invaluable. So I don't think it's an issue of if you ever use the software for making form work as more as or similar software. It's a matter of when. Anybody, any other questions? John, you're muted if you're talking.
Whoops, sorry about that. I don't see the any right now, at least in the YouTube chat. The ticker along the bottom, so it tells you where you can send them if you want to send something via email. And Rod, I'll pull us back out and let you kind of wrap up, and we'll see what kind of questions come up.
Okay.
Nothing yet here, Rod, if you want to.
Okay. I'm just gonna go through what I would a drawing file that. This is one of the things that I find as a limitation to the software is it does not allow you to do certain things that you're trying to do, and it doesn't allow you to snap to certain nodes. For example, it doesn't allow me to dimension this as a 3D item. You're going to have to do that outside of this software. One thing that is good about it, though, is if you can get most of what you want that's on here, you can export this out, for example. And if I come back over here to my drawing and go back to my parameters and change this example to 14, we'll say, make that 12, and then make that 5. We'll make that 3 feet 8. This will update, and then if I save it here, I can come over to here, and it basically redraws it for me. And then I can push that back out or save that as a PDF. This is one of the advantages to having a parametric software where it allows you to pick and maintain like a template of some sort. And then once you do that, you can just crank out a bunch of drawings. You can come in here, for example, and have, we'll say that you have a hole that's cast into the side of this thing. And, depending on where that is, you could have that located on your drawing, okay, that's over here. And again, you'll indicate where that is on the drawing, but you can either turn on or turn off the feature. So some of them maybe have a hole or a riglet, and then some don't. So you could have this thing have everything, a left return, a right return, holes in it, those kinds of things. What's good about something like this is you can build your models. And that's what the whole parametric element of it. You build especially for the handset world, they could take these things, and conversely, you could do the same thing for your form work. Once you've created it and define your parameters, take a little bit of time to do that. But once you've done that, you can turn on and off those features within the timeline, and then go back to the drawing file and get it to spit out what you want it to spit out. That's one big, huge time saver in terms of ticketing. And then the second thing is if you have parts that you want to cut out, whether it's on the CNC or directly onto a foam cutter, for example, you can do the same approach with the parametric software. So. You're still muted.
Sorry. Here's a question that came in. What has the 3D modeling done in terms of meeting tolerances or achieving tolerances?
So the modeling itself is invaluable, and it has we set ours up to be within a 32nd of an inch in terms of model. In terms of what we're doing in terms of the cuts, we were blown away. Our very first, so we bought our CNC in November of 22. And when we cut this first column out here, this was a 28-foot, 6-inch or a long column. By the time we set this thing up from this end to that end, it was within a 16th of an inch. Okay. And what I mean, like 16th of an inch, like, see, so we cut out a rail that had that emphasis on it, which you can kind of see on here. So it kind of comes down and then it straightens out here at the bottom. That thing was within a 16th of an inch. Okay. So that's well within tolerance. And we were just kind of blown away at how well we were able to integrate that directly into the formwork. That's one of the reasons why, to the extent that you can, I mean, it's basically almost zero tolerance when you look at small handset stuff like these, like the bollard and even these big columns that we ended up doing that were on here, they practically had no issues in terms of whether it was width or length. I'm amazed at how well it does. The only issue you have is when you sharpen bits. If you send off your bits on your CNC, that tends to make your tolerance of putting those things together a little bit tighter. And so you just got to make sure you compensate for that, add an extra couple thousandths of an inch width-wise. So instead of saying, hey, this is 0.75 inches wide, you might say, hey, it's 0.78, or you might say it's 0.77 inches. But that's the only other issue we've ever really had is if we've made it to where the tolerance is a little bit too tight. We actually use calipers on the wood and on the bits when they come back, so that when we know back, we kind of go back and push out on the software. If you go back and kind of look on the software here for cuts in the library, in the tool library, when we look at our things like this, you might come into, in this particular case, we have a 3/8 inch end mill, and I'm showing that there's a diameter that's on there. We may end up having to come in here and adjust that diameter to a little bit smaller, because we know that if we know that it's smaller on the actual bit, it's not going to cut as wide. So we'll come back in here and adjust these as we need to in between individual cuts.
Okay, great. Thanks, Rod. I don't see any other questions. We're getting right at the hour mark here. Anything you want to say, and just in conclusion and wrapping up here?
If you have any questions, if you want any one-on-one stuff, just let me know. I mean, I'm happy to share any of this stuff, any of these folders, or any of that kind of stuff that's on here. I just think that this particular product integrates really well into the kind of world and the space that we're working in. It prevents you from having to learn yet another software. I think that's the biggest thing in general. You can get away with, if you understand AutoCAD, you can integrate this pretty quickly into your production. So.
All right. Well, thanks, Rod. We appreciate you taking the time to put this session on today, and we appreciate all those out there who are viewing it live. And if you want to watch it again, it'll be up on the YouTube channel here shortly after this episode concludes. And Rod, thank you for sharing your expertise and time with us. We really do appreciate it.
Sure thing.
Thanks, everyone.